Chandrayaan-2 is the second lunar exploration mission developed by the Indian Space Research Organisation, ISRO, after Chandrayaan-1. It consists of a lunar orbiter, the Vikram lander, and the Pragyan lunar rover, all of which were developed in India. The main scientific objective is to map the location and abundance of lunar water using Pragyan rover, and ongoing analysis from the orbiter circling at a lunar polar orbit at an altitude of 100 kilometers. Today Global Updates analyzes the historic mission of ISRO with available details on Public Circle. Let's get started. Subscribe to Global Updates for videos like this. The mission was launched on its course to the Moon from the second launch pad at Satish Dhawan Space Center, on July 22, 2019 at 2:43 p.m. IST, by a geosynchronous satellite launch vehicle Mark III, GSLV Mk3. The craft reached the Moon's orbit on August 20, 2019 and began orbital positioning maneuvers for the landing of the Vikram lander. Vikram and the rover were scheduled to land on the near side of the Moon, in the South Polar region, at latitude of about 70 degrees south at approximately 1:50 a.m. on September 7, 2019 and conduct scientific experiments for one lunar day, which approximates 2 Earth weeks. Through this, India plans to become the fourth nation to land on the Moon, and the first nation to reach the South Polar region of Moon. However, the lander deviated from its intended trajectory 2.1 kilometers, 1.3 miles, altitude above Moon surface, and had lost communication when touchdown confirmation was expected. Initial reports suggesting a crash have been confirmed by ISRO Chairman Dr. K. Sivan, stating that the lander location had been found, and it must have been a hard landing. As of September 16, 2019, ongoing efforts are being made by ISRO in coordination with NASA, in hopes of restoring communications with Vikram. Communication attempts will likely cease on September 21, 2019, 14 days after Vikram's landing attempt. The orbiter, part of the mission with 8 scientific instruments, remains operational and is expected to continue its 7-year mission to study the Moon. On November 12, 2007, representatives of the Russian Federal Space Agency, Roscosmos, and ISRO signed an agreement for the two agencies to work together on the Chandrayaan-2 project. ISRO would have the prime responsibility for the orbiter and rover, while Roscosmos was to provide the lander. The Indian government approved the mission in a meeting of the Union Cabinet, held on September 18, 2008, and chaired by then Prime Minister, Dr. Manmohan Singh. The design of the spacecraft was completed in August 2009, with scientists of both countries conducting a joint review. Although ISRO finalized the payload for Chandrayaan-2 per schedule, the mission was postponed in January 2013 and rescheduled to 2016 because Russia was unable to develop the lander on time. Roscosmos later withdrew in wake of the failure of the Phobos Grunt mission to Mars, since the technical aspects connected with the Phobos Grunt mission were also used in the lunar projects, which needed to be reviewed. When Russia cited its inability to provide the lander even by 2015, India decided to develop the lunar mission independently. The spacecraft's launch had been scheduled for March 2018, but was first delayed to April and then to October to conduct further tests on the vehicle. On June 19, 2018, after the program's fourth comprehensive technical review meeting, a number of changes in configuration and landing sequence were planned for implementation, pushing the launch to the first half of 2019. 2 of the lander's legs got minor damage during one of the tests in February 2019. Chandrayaan-2 launch was initially scheduled for July 15, 2019 at 2:51 IST local time, with the landing expected on September 6, 2019. However, the launch was aborted due to a technical glitch and was rescheduled. The launch occurred on July 22, 2019 at 9:13 UTC, 14:43 IST, on the first operational flight of a GSLV Mk3M1. The primary objectives of the Chandrayaan-2 lander were to demonstrate the ability to soft land on the lunar surface and operate a robotic rover on the surface. Scientific goals include orbital studies of lunar topography, mineralogy, elemental abundance, the lunar exosphere, and signatures of hydroxyl and water ice. The orbiter will map the lunar surface and help to prepare 3D maps of it. The onboard radar will also map the surface while studying the water ice in the south polar region and thickness of the lunar regolith on the surface. ISRO selected 8 scientific instruments for the orbiter, 4 for the lander, and 2 for the rover. While it was initially reported that NASA and ESA would participate in the mission by providing some scientific instruments for the orbiter, ISRO in 2010 had clarified that due to weight restrictions, it will not be carrying foreign payloads on this mission. However, in an update just a month before launch, an agreement between NASA and ISRO was signed to include a small laser retroreflector from NASA to the lander's payload to measure the distance between the satellites above and the micro-reflector on the lunar surface. Payloads on the orbiter are 1. Chandrayaan-2 Large Area Soft X-ray Spectrometer, class, from ISRO Satellite Center, ISAC, makes use of X-ray fluorescence spectra, to determine the elemental composition of the lunar surface. 2. Solar X-ray Monitor, XSM, from Physical Research Laboratory, PRL, Ahmedabad for mapping major elements present on the lunar surface. 3. Dual Frequency LNS Band Synthetic Aperture Radar, DFSAR, from Space Applications Center, SAC, for probing the first few meters of the lunar surface for the presence of different constituents, including water ice. DFSAR is expected to provide further evidence confirming the presence of water ice, and its distribution below the shadowed regions of the Moon. It has lunar surface penetration depth of 5 meters in L-band. 4. Imaging IR Spectrometer, IIRS, from Space Applications Center, SAC, for mapping of lunar surface over a wide wavelength range, for the study of minerals, water molecules, and hydroxyl present. It works up to 5 microns, an improvement over previous lunar missions whose payloads worked up to 3 microns. 5. Chandrayaan-2 Atmospheric Compositional Explorer 2, CHASE-2, Quadrupole Mass Analyzer from Space Physics Laboratory, SPL, to carry out a detailed study of the lunar exosphere. 6. Terrain Mapping Camera 2, TMC-2, from Space Applications Center, SAC, for preparing a 3-dimensional map essential for studying the lunar mineralogy and geology. 7. Radio Anatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere, Dual Frequency Radio Science Experiment, RUMBA DFRS, by SPL for the studying electron density in the lunar ionosphere. 8. Orbiter High Resolution Camera, OHRC, by SAC for scouting a hazard-free spot prior to landing. It will later help prepare high-resolution topographic maps and digital elevation models of the lunar surface. OHRC has spatial resolution of 0.3 meter from 100 km polar orbit. The payloads on the Vikram lander are 1. Instrument for Lunar Seismic Activity, ILSA, MEMS Base Seismometer by LEOS for studying moonquakes near the landing site. 2. Chandra's Surface Thermophysical Experiment, CHASE, thermal probe for estimating the thermal properties of the lunar surface. 3. RUMBA LP Langmuir probe, for measuring the density and variation of lunar surface plasma. 4. A Laser Retroreflector Array, LRA, by NASA, Goddard Space Flight Center, for taking precise measurements of distance between the reflector on the lunar surface, and satellites in lunar orbit. The microreflector weighs about 22 grams and cannot be used for taking observations from Earth-based lunar laser stations. Pragyan rover carries 2 instruments to determine the abundance of elements near the landing site. 1. Laser-induced breakdown spectroscope, LIBS, from Laboratory for Electro-Optic Systems, LEOS, Bangalore. 2. Alpha particle-induced X-ray spectroscope, APXS, from PRL, Ahmedabad. 2 landing sites were selected, each with a landing ellipse of 32 km long by 11 km wide. The prime landing site, PLS 54, is at 70.90267 south, 22.78110 east, 350 km north of the South Pole, Aitken Basin Rim, and the alternate landing site, ALS 01, is at 67.874064 south, 18.46947 west. The prime site is on a high plain between the craters Manzinu C and Sympelius N, on the near side of the Moon. Vikram lander separated from Chandrayaan 2 on 20 hours 8 minutes and 3 seconds UTC, September 6, 2019, and was scheduled to land on the Moon at around 2023 UTC. The descent and soft landing were to be done by the onboard computers on Vikram, with mission control unable to make corrections. The initial descent was considered within mission parameters, passing critical braking procedures as expected, but the lander's trajectory began to deviate at about 2.1 kilometers, 1.3 miles or 6,900 feet, above the surface. The final telemetry readings during ISRO's live stream show that Vikram's final vertical velocity was 58 meters per second, 210 kilometers per hour, at 330 meters above the surface, which according to the MIT Technology Review, is quite fast for a lunar landing. Initial reports suggesting a crash were confirmed by ISRO Chairman Dr. K. Sivan, stating that the lander location was found and that it must have been a hard landing. Radio transmissions from the lander were tracked during descent by analysts using a 25-meter radio telescope owned by the Netherlands Institute for Radio Astronomy. Analysis of the Doppler data suggests that the loss of signal coincided with the lander impacting the lunar surface at a velocity of nearly 50 meters, 164 feet, per second, as opposed to an ideal 2 meters, 6.6 feet, per second touchdown velocity. The mission's orbiter used thermal imaging to locate the lander. Unconfirmed reports, citing an ISRO official, stated that the lander was intact, but there has been no official announcement by ISRO on the lander's physical condition. ISRO's chairman, Dr. K. Sivan, tasked senior scientist, P.S. Goyal to head the Failure Analysis Committee to look into the causes of the failure. As of September 16, 2019, ongoing efforts are being made by ISRO in coordination with NASA, in hopes to restore communications with Vikram. The orbiter part of the mission, with 8 scientific instruments, remains operational, and will continue its 7-year mission to study the Moon. On a statement, the ISRO stated that 90 to 95% of the mission is a success, since the orbiter, which is still in good condition, carries the major payloads. We can hope ISRO will soon identify the reasons for the unsatisfactory performance of the lander and will correct it in the coming missions. Thanks for watching. Subscribe for more videos like this and press the bell icon for instant notifications. Hit the like button if you find the video interesting and kindly provide your feedback in the comment section. This will help us improve.